We don't want Allison to feel left out, so I'll put this right up in her face. This is what we're doing right now. But I sent her an email with the attachment, so she might have already printed it out, and she can see the problems that we're doing now. So if we look at this first one here, it says a standing wave is formed in a stretched string that is 3 meters long. Draw a sketch of the first and second harmonic. And I want to know what the wavelengths are for those first two harmonics. Go ahead and take a second in your notes to just practice drawing those wave patterns. You have them already in your notes for the first and second one, but just maybe draw them again here for the first two harmonics of this standing wave. Okay, so you all have these drawn and you know how to draw them. They're sitting there in your notes. As I said before, just make sure when you draw these, don't draw them any wider than the first one here. They should all be the same length or have the same width here on your paper. I'll put the lines like this on sometimes just to keep me all straight here on the board, but just when you draw them, make sure they're all the same length. I put my 3 meters up there just to label it for myself so we can see it because we know the length of that string is 3 meters here. We want the wavelength of the first and the second harmonic. Okay. Let's do the second one first. What's the wavelength of the second one?
It's going to be 3 lambda, or 2 lambda 2 over 2.
But what would that be equal to? If I'm just looking at our picture.
3.
Just 3. We can use the equation to get there. But here, remember, this is how much of a wave here? That little piece is half. The whole thing here is, that shows 1 full wavelength. So this lambda here is just going to be 3 meters. How much of a full wave is this up here? A half. So what would my wavelength be up here if that's half? If half is 3, then a whole wavelength here would be 6. You don't have to answer the question by looking at your picture, but you should be thinking about what these numbers represent and what you're really saying here when you get the wavelength or you know the length here of the string. We can definitely use our equation. You could go up there and say L is equal to n times your lambda n over 2. And you could use that to solve that equation for the wavelength. All right, so for the first one, I'd have 2L is equal to 1 times lambda 1. I'm just putting the 1 in there as a reminder of what I'm doing with those n's. If our L is 3, this is how we get that 6 meters there. There's nothing wrong with doing that math there, but you could probably answer that question by just looking at the picture there, if you've drawn. And then you could do the same thing for your lambda 2, the second harmonic down here. You'd have the 2L is equal to 2 times lambda 2. So I'm just multiplying up by the 2 to get rid of that fraction, and then plugging in the harmonic that we're on. The second one here is just These 2's cancel out, and that's how we got the 3 meters for lambda. And go ahead and put the 2 here on this end. This is lambda 2 right there. You guys see that? Okay. Make sure you don't mix up the length of the string with the wavelength of whichever harmonic you're on, because they're both going to be in length units. They'll both be in meters or centimeters or whatever your length units you are using are. And sometimes people mix those up. So our second one on here gives you the wavelength of the third harmonic on a string, tells you it's 5 meters. Draw a sketch of that third harmonic and determine what the length of that string is. So the third harmonic will look like this. We don't know the length, but I think we do know the wavelength of this third harmonic. Is that correct? What is that wavelength? Is it 5 meters? Okay. How do you find the length of the string? Backwards? Backwards what?
From our equation.
Backwards from what, last time you mean?
Yeah.
Yeah. I mean, just use one of your equations over here. Remember, the length is just equal to some multiple of these half wavelengths. So the length is equal to n times your wavelength over 2. We are on the third harmonic here, so our L is equal to 3 times lambda 3 over 2. So you get 2L over 3 is equal to lambda 3, or the L here is 5 meters, or the wavelength is 5 meters. Yeah, we're done right here, because we're solving for the length this time, is that right?
Yeah.
Yeah, so just plug in our 5 meters, 3 times 5 meters here, over 2, and then you get 7.5 meters there for that length. So that's it for the L. You notice there maybe that I accidentally kind of started over here, started solving over here, and I just did the way we did the last one. But this is a place where you might get mixed up because this is in meters here, you might plug in 5 meters here and feel like it's okay because that's in length. That's where from the beginning, just make sure, if I tell you the wavelength of the third harmonic is something, make sure you write it down as lambda 3. Don't just call it lambda, don't call it L, but make sure you give it the correct variable that goes with whatever it is, because those things that are in meters there, the length and the wavelength, are things that people mix up a lot. So just be careful with that.